This event today is a pretty special event, a unique event, and it's one built around building community and information sharing. So I would like to just make a few opening remarks before we get to the topic of today, and I'd like to comment about community. I'd like to say a few things that'll tee up today's topic of interest, and then also introduce our speaker, of course. And as I've been thinking about today and how we all are engaging with this emerging technology, it is very exciting times for sure. And for me, it's remarkable to observe how multidisciplinary today's AI is. And when you think about AI and the disciplines that must come together, are coming together, we're talking about software and algorithm engineering, data science and analytics, robust statistics and applied mathematics, hardware implementations, and high-performance computing, information theory, and the list just kind of goes on, right? And so what I am observing, both at NIST and then also at the federal interagency level, there's a call for a new level of multidisciplinary collaboration. And I'm observing that taking place here at NIST. I'm observing that taking place within the federal interagency. And so today, we are co-hosting. So NIST is hosting, but it's sponsored by, if you will, two communities. We have with us both the federal AI R&D interagency community, and I'll talk a little bit about that. And then we have the NIST community for AI. And so depending on who you're sitting next to, you may be one or the other, and I'll give you a moment to identify yourselves. But this is intentionally a commingling, and so if feel free to reach out to people during but of course after, and we even have an informal luncheon to help facilitate some of that. Okay, so let's. Some of us do not know much about the others community. Okay, so we'll take some time to talk about that. So within the Office of Science and Technology Policy, there's a National Science and Technology Council, and that council is a primary advisory council to the President and his staff over science technology. And within there's this subcommittee, a long-term subcommittee, one that's congressionally mandated by Congress, and it's the Networking Information Technology Research and Development Subcommittee, NITRD. And my colleague Fazil de Souza is an executive assistant to many groups, including NITRD and the NITRD, the group that we're talking about and hosting here today. And so NITRD is about facilitating collaborations around research in networking and information technology. They track federal investments by mandate as well. And there's a family of interagency working groups, and I didn't prepare the list today, but there's many, and some of you in the room participate on one or more of those. The newest member to the family of interagency working groups is the AI R&D IWG. And today, we are together being hosted by the discussion series, the AI R&D discussion series group that supports this interagency working group, and helps with sharing awareness, bringing the community together around topics of research, and also fostering this kind of community opportunities for collaboration and awareness. The new AI R&D Interagency Working Group is chaired by Henry Kotz from National Science Foundation, and Henry was registered, but I don't think I saw him here at this point. Also, Jeff Allstott from the IARPA agency. Membership here is really made up of the federal AI R&D researchers and program managers who have portfolios and manage portfolios of AI R&D investments, and promoting community, which is much about what we heard today. Now, where does this fit in sort of the strategy of priorities for the White House? AI has remained a national priority coming out of the Obama administration, never hit the floor, continues with the Trump administration. And in the bottom right is this new NITRD AI R&D Interagency Working Group. building a community of practice around AI research. If you follow up the chain to the left and to the top, you actually see sort of the importance, the emphasis that the White House is putting on this activity. They created in May a special select committee on artificial intelligence at the top. This is a cabinet-level advisory group responsible for setting R&D direction, oversight, and they're charged with building and continuing collaboration coordination across the federal enterprise, but also maintaining U.S. competitive and leadership in this research area. So next down is a longer-standing machine learning artificial intelligence subcommittee. This is structurally, it's in between, and in terms of rank and file and status of members, it kind of fits in between. It's the implementation arm of the select committee, and then the IWG down at the bottom right is really where the rubber meets the road with the researchers. Now NIST has roles riddled all through this in leadership. Our director, who also serves as the Department of Commerce Under Secretary for Standards and Technology, Walter Copen, he's a member of the Select Committee. And so all the agencies that really have R&D investments from the 18 budget are represented there. Our own Dr. Charles Romine, the director of the Information Technology Lab, he co-chairs out of the Machine Learning and AI Subcommittee. I'm privileged to be a primary representative for NIST in the IWG. And oh, by the way, we're honored that our own Cammie Roberts from the Information Technology Laboratory is the director of NITRD. And so NIST is playing its role, and I'd like in a moment to talk a little bit more about what NIST does. So anyway, that's the IWG, the discussion series that you're part of. If you're from the interagency, would you raise your hand so we could just see who's here from the interagency? Oh, thanks so much for being here. And NISTers, if you would please reach out, make them feel welcome. They would love to know about the kinds of things that you're working on. All right, so that's the one community. Now we're bringing together with the second community, which is the NIST AI community of interest. So if you're less familiar with NIST, this is our mission statement. And what I've done is I've gone through and I've simply underlined the different elements or factors of our mission that I think are impactful to or by AI. And so if you look at the word spots, innovation. So certainly the new wave of AI is innovating. Industrial competitiveness. Industry's leading much of the research and development of what we're seeing in terms of emerging technology. The core of NIST, measurement science, standards, and technology. All that should be brought to bear, and it has been for 100 years in emerging technology, and it should also for emerging AI technologies of today. Enhance the economic security. You know, we all see sort of a global AI Cold War kind of phenomena going on, and improve the quality of life. The impact of what we're all working on, thinking about, trying to support, really can have great societal impact. So, a couple different ways to think about AI at NIST. We have two dimensions here represented in this graphic. Horizontally, you've got AI for NIST, and vertically you have NIST for AI. Thinking about AI for NIST, we're a diverse laboratory, and I'll come back to these areas in a moment, but virtually every project lead, and many are represented here in this room from our NIST community of interest, are looking at this machine learning, and we're either looking to do novel things with it now, we're trying to figure out what can it do for us in the near term. So, AI for NIST. And to support this, we have created, what we have gathered together here are AI community of interest. The purpose is to coordinate and leverage collective AI expertise and resources around the agency, and to track activities and look for opportunities for collaboration. We are 170 plus members strong, open to all staff and NIST associates. We have the symposium series, which is what you're participating in today. We have a SharePoint to support the community, and for internal purposes now, we have a NIST catalog of artificial intelligence projects and activities. And in there, we have 55 AI-related research projects represented by many of the people in the room today, and also 13 identified AI-related standards activities. So there's a lot going on, and when you look topically, kind of holistically across NIST, these are the topics that pop up that are either being impacted by AI or they're actually serving to innovate and drive AI. And you see a very diversified list here, and we won't take the time to go through it. But there's quantum AI, there's neuromorphic, there's robotic agility, and the list goes on and on. A bunch of image understanding. We have this rich legacy in information search and summarization, natural language processing. So I said I wouldn't go through the list, but here I go. All right, so that's a little bit community of interest. So that's the second community that's here being represented. What about NIST for AI? And that's what's represented in this graphic. When you think about AI technologies and emerging technologies, and these technologies, they're data-driven and they're probabilistic. And so they bring certain things to the table that are worthy of extra consideration. So when you think about pillars or categories or characteristics that lead to trustworthy AI, we're talking about the need for these technologies to be reliable, for them to be resilient, for them to be explainable, for them to be secure, for them to be privacy enhanced. And NIST has, in some of these pillars, decades of deep, rich work. Some of these are more young, but very, very important. And the pillar of explainability is actually an area that we are still working to kind of get momentum and work with the community, because none of this happens solely at NIST. As the NISTers here know, this all happens in the context of community. All right, so with explainability, we're going to segue, and that's going to jump us down into a kind of a subset of explainability, is needing to understand the underlying decision-making and the bias that's taking place, potentially. And so things like latent bias, unwanted, harmful, even illegal bias. And this has been framed under the topic of fairness. And so this leads us to today's topic. See, I told you we'd get there. So, it is really a privilege to be able to introduce our guest speaker today. Dr. Raman Chowdhury. She's from Accenture, and I'll read some of the excerpts from her impressive biography. Her passion lies at the intersection of artificial intelligence and humanity. She's a practicing data scientist and AI developer. She's a global lead for responsible AI at Accenture Applied Intelligence, where she's working on cutting-edge technical solutions for ethical, explainable, and transparent AI. Raman is an international speaker and global thought leader, and she's been named by Information Week as one of the 10 influential AI machine learning experts to follow on Twitter, one of the BCC's 100 Women for 2017, recognized as one of the Bay Area's top 40 under 40. And the impressive list goes on. So Dr. Chowdhury also holds 2 undergraduate degrees from MIT, a master's degree in quantitative methods of social sciences from Columbia University, and a doctorate in political science from the University of California. It's my pleasure now to introduce Dr. Chowdhury, Raman, and as she comes to present perspective, experience, and implementation, which I applaud Accenture for, of quantifying AI fairness. Let's welcome Raman. That looks like the right one.
That is. Thank you very much. Great. Well, thank you for that really wonderful introduction. It's great to learn more about NIST and all the great work you're doing, because on my end in industry, it's often difficult for us to see what other folks are doing unless it's very publicly available. So this is an honor and a privilege for myself and my colleagues at Accenture who are with me as well. If you have any questions afterwards, we are open to talk to you. I think we'll be here a little bit after, so we will have some time for Q&A. And so just to start the introduction, fairness is a very interesting word, right? We don't think of us as building technology or building products or things to be fair. It seems like an intangible, nebulous concept. And interestingly, so is this concept of responsible or ethical AI. And actually, it was a very specific decision that was made for my title to not be ethical AI lead and responsible AI lead, because there was fear that ethics implies this framework of morality, which is very culture and context and often individual dependent. So fairness carries that same sort of weight. So what I'm here to talk about today is how do we actually define and deploy algorithmic fairness? Why are we using this word of fair? And what is the legal precedence for it? And how have we at Accenture developed the fairness tool? So our fairness tool actually launched in May. And just actually in the last week, both Google and IBM have launched similar fairness tools. So Google's is called What If, and IBM's is called Fairness 360. Both of them are open source. And I will talk about them and do a compare and contrast a little bit later. But just a little bit about my team. We are dedicated to creating human-centric artificial intelligence. We encompass social, regulatory, and economic impact of the technology from end to end. And we also serve as a starting point for governance within Accenture, and actually increasingly for our clients as well. So I am charged with creating our internal AI governance at a company like Accenture. So just to give you an example of scale and scope, we are approximately 450,000 employees all around the world. We are a very, very federated organization, incredibly decentralized. So, as a poli-sci buff, and I'm sure there are some in this room, thinking about how you create a system of governance for, basically a company the size of a country that geographically encompasses the whole world is not only an interesting challenge, but a daunting one. So that actually currently is, in my opinion, the most interesting part of my job, is figuring out how we govern without regulation stifling the innovation, and also respecting the cultural context of all the work that we do around the world. So I have a co-lead who unfortunately could not be here today. Her name is Deborah Santiago, and she's senior leadership in Accenture Legal. And we're an interesting duo, right? We're a technologist, political scientist, and a senior person in legal. So we're, in my opinion, encompassing the broad range that artificial intelligence is able to impact, and also highlighting the need of a broad range of skills in order to understand, create appropriate products, and manage and deploy properly. On the right-hand side is just a bunch of the affiliations we have. We are very, very actively engaged with all of these groups. Actually, the Fairness Tool was prototyped at the Alan Turing Institute in Cambridge. I'm a member of the Royal Society of the Arts and actually sit on the board of their Citizens AI Committee. We're hoping to replicate something like what they're doing in the US. The Citizens AI group gets a citizen's perspective on artificial intelligence by treating it like a jury trial, where citizens are tasked, they're educated on a topic and they're tasked with answering a question. In this case, the question was, in which cases should AI not be used? I'm actually using it as a prototype, again, thinking about governance, for how to get quality citizen engagement. As some people in this room may know, that some of the FCC comments on net neutrality, particularly the ones that were for net neutrality, were actually turned out to be fake, and they were bot generated. So how do we actually properly engage citizens so that we're not getting a self-selected sample of either interested lobbyists, citizens with agendas, or literally bots? So I'm working a bit on that. At the WEF, I'm managing a project on responsible AI for the board. If any of you were tuning in to the AMNC meeting that just happened in Tianjin this week, Kay Firth Butterfield, who's leading up the AI initiatives at the Center for the Fourth Industrial Revolution, presented our initial prototypes, or our initial mock-ups of what the product would look like. Partnership on AI, sit on the Fairness group. I'm working on a project called Diverse Voices, similarly about how organizations and companies can engage activists and local community members in a meaningful way. And then IEEE sit on P7003, and actually maybe shouldn't go beyond this room, but Accenture is about to join an auditing body with the IEEE as well. So there's a lot of really, really exciting things happening in artificial intelligence. It is a global phenomenon that is globally handled. So this is exciting because this is true globalization happening in every aspect of this technology. So a bit about what I think about when I think of artificial intelligence. So the top half, we all know this. There's this opportunity to unlock trapped value. What we think is possible in the very near future is amazing. In fact, the world we live in today versus the world we lived in 15 years ago is amazing. However, on the bottom end, we have these two branches to think about. One is the compliance challenge, and that is a known but constantly evolving space. So the European Commission just had their group on artificial intelligence meet this week. They're moving very aggressively and very assertively to start regulating. So we will see the compliance waters shifting over the next year, year and a half. So there is the evolution of the legal space that's going on. On the other end, there is these unintended consequences. And this is where things, in my opinion, are very, very interesting. Beyond technology, beyond AI, we're seeing the rise of what one might call consumer activism and often shareholder activism, where individuals are holding companies to a higher standard than just saying, oh, we're legally compliant. We are now asking companies to do the right thing. And when we think of unintended consequences, we understand that it was often not the intent to do something bad, but the impact of what a company may do, a technology they may deploy, might be very, very negative on a particular subset of the community. And what people are asking for is the appropriate addressing and redressing of these unintended consequences. And today, we actually don't have good mechanisms for that, particularly with artificial intelligence. And that's what my community, the Responsible AI Global Community, seeks to do. So every year, I started this job about a little over a year and a half ago, almost 2 years ago at this point. And every year I have a theme. When I first started, my theme was awareness. Frankly, at that point, which a year and a half ago does not sound like a very long time, but frankly, at that time, people didn't understand what my job was. I spent a lot of time explaining why we need ethics in AI today. Everybody was more worried about Terminator and robots and HAL than understanding what an algorithm was and how algorithms were influencing us today. 2018, we moved from virtue signaling to positive action. What does that mean? So we're now in a space where we all agree, mostly, that we need ethics, fairness, etc. However we may view or shape those words, we are in agreement that there needs to be some addressing. There are very few people that I run across today, compared to almost a year ago, who don't see the point or purpose of it. However, virtue signaling is great. Of course, we all will raise our hands and say we should be ethical, we should do the right thing. But how do we do the thing? And this is what inspired the fairness tool. What we need to do is create ways for scientists, who often, by the way, may not be trained in the kinds of investigatory analyses that would be required to poke and prod at a model for fairness or equal outcomes, all the things I'm about to talk about. So what I did was prototype and create the fairness tool. And this is why Google and IBM have also followed suit, and they too have launched their fairness tools. What I see coming in the year ahead is agency and accountability. There's this tension here between this desire and the value of democratizing artificial intelligence, not just in the sense that we want to use it in a lot of our products, tools, and projects, but also that we want people to be educated so they can use it themselves. It is certainly possible. Now, the tension with that is, okay, well, how do we regulate it? How do we create the right sort of mechanisms? And again, if there's any poli-sci people in this room, what I use is in understanding a system of governance. It's actually a paper on congressional oversight that a former advisor of mine wrote in 1982 called Police Patrols and Fire Alarms. And his premise, the conversation he was having was about how does Congress regulate itself? Similarly, Congress, highly decentralized, very big body, people all over the US, right? How do you regulate a body like that? What he argued, and what I actually use that framework for in talking about governing AI in a way so that it doesn't stifle innovation, and in his case it was so it doesn't stop Congress from doing their job, was that instead of having a police patrol that goes around and pokes and asks questions and tries to find something wrong, what you should do is enable the way people pull fire alarms when they see a fire, educate people to understand what a fire looks like algorithmically, and pull the right lever so they can escalate the situation. But of course then, you need a system of escalation. You need a system and a chain of accountability. And so my prediction for the upcoming year is that we will see a lot of discussion on accountability, governance mechanisms, and we will see the regulatory space absolutely exploding. I referred to the EU High Commission on AI earlier in this talk. As I mentioned, their first meeting was this week, and they are aiming to have high-level ethical principles for the European Union by December. And if you follow the pace at which the EU moves, that is a blistering pace for them. That is extremely fast, and I think it's a signal that they're moving rather quickly on this. So the first part of my talk, how do we define and understand responsible AI? What are we responsible for? Who is responsible, and what do we do about this responsibility? So there's an acronym in the responsible AI space, and it's FATE. It was actually FAT, but that's, we're not very good at making up acronyms. So we've started to add an E, so it's FATE. Fairness, accountability, transparency, and explainability. So what do we mean by fairness? I'm going to go more in depth when I talk about the fairness tool. So number one, are there factors influencing the model outcomes that should not be? And specifically, legally, are any of these protected classes as defined by either US law or whatever international law you're complying with? Second, do we have an expectation of similar outcomes for different subgroups? And again, these would be subgroups that are unrelated to the output. And when I talk about a definition of what is and is not fair, it actually seems kind of intuitive and obvious. Second is accountability. Within an organization, what is the chain of command on deciding what do I do with a potentially biased outcome? The other thing is also, how do we create an institutional framework so that decisions don't seem arbitrary? What we do not want is one governing body of a few people who are making judgment-driven personal decisions on what should and shouldn't be used or done. What we need is actually a reliable framework so that any educated person could come to the same conclusion, or as similar as possible. At the very least, we could trace it back to an institutional design. Third is transparency. How do we understand? Do we understand how the model works? And transparency is an interesting one. So what is transparent maybe to you and me is not transparent to the average person. And when I create things, I think about what impacts an average consumer, and also what is the consumer able to do with that information? So I have an article that I wrote about transparency and agency, and what I say in it is that transparency is useless without agency. It does not matter if I tell you, here are the 10 reasons why you didn't get a loan, if you can't actually take an action on it. Of what use was the fact that I told you why I came to the outcome I did? I still hold all the power. I still made a decision. You have no system of addressing or redressing a wrong if you think there is a wrong. So yes, transparency, however, I'm pushing for agency. And finally, explainability. And can we identify why an output was arrived at? Explainability also is an interesting one. Again, to people like you and me, what is explainable is not what is explainable to an average person. How do we then move from explaining to understanding? And when Mark Zuckerberg was here testifying to Congress, he was talking about end-user license agreements and how Facebook is fully transparent and explain how data is being used. And he was stopped in the middle of a sentence by a senator who said that, look, we all know that end-user license agreements are what companies use so that they can figure out how to get around the end-user license agreement. And it was pretty strongly worded, but essentially said that, look, you put that up for yourself, not for the consumer. So our drive is to make things for the consumer. So rather than explainability, which is an end-user license agreement, which we've all read through, unless you specifically work in that kind of law, it's very difficult to decipher. How do we then move to understandability? And I will say companies like Facebook, taking that kind of criticism, have done more to make their privacy policies and their usage rules better explained and more intuitive within the user design. So there's an interesting evolution of both the transparency and explainability space. So I'm going to talk very quickly about different kinds of bias. So this is the bias I think most of us are familiar with, this idea of experimental bias introduced by design or by data. So, what is your measurement, the thing that you think you are measuring? That is actually often a problem. So for example, in predictive policing models, often a measurement of crime is used. Now the measurement of crime is not actually the true amount of crime that occurs. It is the number of arrests or the number of calls made to the police. And there is a pattern to that. It may be regionally driven, it could be socioeconomically driven, it could be racially driven. But given that those patterns exist, there might be a bias that can creep in due to that. Second is responsive reporting bias, what I often call the Yelp effect. People only go on Yelp when they either love a place or they hate a place. You don't go on Yelp when you think a place was just average. It's pretty rare. So if you were to do an assessment of restaurants with a low enough N, only based on Yelp reviews, you would get a very skewed result. And then finally, design bias. What assumptions are you making about your model and the applicability to the question? And are you engineering a feedback loop? So just as a preview of the next thing that I'm thinking about, now that we're productizing this fairness tool, I'm thinking a lot now about feedback loops. So specifically, if you have measurement bias and a feedback loop, what happens? You basically are picking up a skewed measurement and then proving your own point. So what I worry about is that once you've deployed an algorithm based on skewed data, it will then self-reinforce by deploying in particular places, acting as if certain actors are certain ways, and then getting the outcome that it assumed it was going to get, and then perpetuating itself. So that's what I'm thinking about at the moment. So this is the kind of bias, as I mentioned, that we're all probably familiar with. It's for us, it's a safe, comfortable space. It's the world we know. It's measurable. It's actually, I'm very happy here because I know I can do things about it. And then here's the part that throws a complete monkey wrench into everything. Even if you had perfect data, so let's say I have no measurement bias, I know exactly how much crime there is in the world, and I can have a perfectly calibrated tool and I put it out into the world, and then I find that actually the world is just an unfair place. And we all know this. The world does not treat us all based on pure merit, right? We are judged by how we look or how tall we are or the clothes we can afford or what our parents did or where we grew up. And this is all true. So data is not an objective truth. It's reflective of pre-existing institutional, cultural, and social biases. So even if I created a perfect model, what I might be doing is perpetuating the status quo. And I know often people want to say that I'm not going to take a political side or make a judgment call on this, but you do. In your inaction, you perpetuate status quo. And that's fine if that's what you want to do, but just recognize that that is what you are doing. You are saying, I'm okay with the way things are in the world, and my product, et cetera, will institutionalize that. So just to highlight different harms that can happen. So when we think about fairness, I think about primary and secondary harms. So this great framework was created by the Future Privacy Forum. And the 4 kinds of primary harms that they identify are loss of opportunity, economic loss, social detriment, or loss of liberty. So this is a specific denial of something to an individual. Primary harms. And many of these are actually legislated against. So for example, with the first one on loss of opportunity, Facebook letting housing advertisers exclude users by race is actually illegal. You cannot do that. Some of it starts to get a little bit trickier when we talk about Amnesty International saying that Twitter is violating women's human rights. Where that came from was the extreme amount of harassment that a lot of women activists get all around the world, particularly from developing nations. For example, people fighting against female genital mutilation or oppressive regimes. And the women are particularly harassed and targeted with violence. So there's a loss of liberty because these individuals are not allowed to freely roam or be safe even in their own homes. So as I mentioned, principles of responsibility. Actually, the slide should have been before the other one. So explainability. Explaining is a top-down method of providing reasonings, but understanding makes sure that your end user is a user-based approach, making sure that the person at the other end of the pipeline is the one adequately receiving the information. And transparency versus agency. Transparency gives you insights into the systems, but agency, again, allows the end user to do something about the outcome, even if that doing something, by the way, is pulling a fire alarm and raising a flag. So the second part is, how do we address this imperative? So what tools exist today, what pre-existing frameworks can be leveraged, and importantly, where are the gaps that exist? So I want to highlight that our practice at Accenture is multidisciplinary. I'm talking today about the technical components of what we do. We actually approach responsible AI with 4 pillars: technical, brand, governance, and organizational. Technical and governance I've talked to a little bit. Brand is actually about how your organization or corporation is viewed in the public and in the media because of their use of AI. AI will become actually the face of many companies. You think about how you walk into a store and there's a greeter and they say hi and welcome to wherever you walked in. A lot of companies are now using front-facing chatbots. For example, Bank of America launched Erica. And this artificial intelligence and these AI interfaces will actually start to become the face of a company. So what does that mean when you launch a product? And finally, with organizational, there's a lot of effort being put behind the future of work. It is a primary concern at Davos. It's a primary concern of many organizations, not just about the automation of blue-collar jobs, but actually of the automation of a lot of high-skilled jobs. So, for example, in the legal space, there's a lot of concern among the paralegal community that some of the work they do, a good portion of the work they do, is already being automated away because we can use so legal literature is a perfect use case for most natural language processing. It is a very specific corpus of information. It is very dense. There's a lot of pages of it. It's something that most humans probably don't want to do, is read through every single case related to a particular law. But AI, or natural language processing, is able to go through massive amounts of documentation and concisely consolidate into something useful. So there's a lot of concern about the future of work. And today, as I mentioned, talking mostly about technical and governance. So technical tools, and this is the part you've been waiting for, right? The fairness tool. So it's based on the concept of predictive parity, what I call algorithmic justice and equality. And this is actually rooted in a Supreme Court ruling from 1971. So post-Civil Rights Act, companies could not exclude explicitly by race. They could no longer put up signs that said no blacks allowed. Instead, what some companies did was find grandfather clause roundabout type ways to limit hiring. For example, in this one company, they required for a college degree, even for entry-level jobs. Now, at that time, there were no African Americans who had gone to college because they had not been allowed to. Very few, if any. And so what the Supreme Court decided was that what is required is the removal of artificial, arbitrary, and unnecessary barriers when the barriers operate invidiously to discriminate on the basis of racial or other impermissible classification. So today we would say that would be race, gender, and ability, and sometimes age. So what this is actually saying, this addresses the language of unintended consequences. It doesn't matter if you didn't mean to do something wrong. If something wrong happens and we are able to prove it, then that is actually not permissible by law. So this has been the basis of a lot of the fairness discussions, going back to some of the earliest papers. This is actually the ruling that a lot of the academic work that I'm relying on to build the fairness tool is based on. It's a very fascinating read. There's actually 3 parts to it. So the first part is about this. Is there discrimination based on these impermissible classifications? Second is actually the organization needs to prove that it is that there is no alternative option that would be better, even if it's a human option in our AI case. And third, they'd have to prove that it is a necessary thing to do. So for example, in this case, this had to do with Duke Power Company's hiring mechanisms and hiring assessments. What Duke Power Company would have to say is something like, well, we needed to create this assessment tool because we could not rely on individuals, because we needed to create a standardized way of hiring people. So it's very interesting. It's actually 3 parts, but the part that people refer to the most is the first part, which is this. So what does it mean to be fair? It's sort of the weighted question. If you're familiar at all with ProPublica and their work on the Compass algorithm, you know these 2 pictures. So the Compass algorithm was created by a company called Northpoint and sold to private prisons. And the goal of it was to help with deciding whether how much of a risk criminals were. The man on the left, Vernon Prater, was a repeat offender in his 40s. He robbed a Home Depot of, I think, about $80 worth of goods and was caught. This algorithm decided he was a low risk. Bishop Borden was 18, first-time offender. She saw an unlocked bicycle and did what maybe some of us would call something stupid but a youthful indiscretion. kind of took a bike she saw and biked it down the street. When someone said, hey, stop, she dropped the bike and moved on. She was convicted of theft of, again, about $80 worth of goods. She, for some reason, was deemed a high risk by this algorithm. This is just one example. There are many papers that go through the COMPAS algorithm and systematically show how this is not just an off case, how this happens repeatedly. And interestingly, Black women are the most harmed and discriminated against by this algorithm. So what does it mean to be fair? What I said earlier was something like, well, there can't be things influencing the outcome that we think shouldn't be influencing the outcome. Now, it would be fair if, everything else being the same, they had committed the same, let's say, committed the same crime, they've exhibited the same sort of criminal behaviors, and they were given the same score. Yet this is a good example of how overwhelmingly the inputs should have been different. So there was something else driving the output. And fortunately, in Wisconsin, where the COMPAS algorithm was used, North Point was sued. So they had to actually release the contents of the survey that they used. And they asked questions like, what did your parents do as a living? Were they divorced? Do you think that people should be allowed to steal bread if they're starving? These are the kinds of questions that were in that questionnaire, by the way. So when we think something is fair or unfair, it is when something is driving an output that shouldn't be. So if I said, this is not about eliminating bias. Eliminating bias and getting to zero bias is actually not quantitatively possible, right? And not even quantitatively desirable, I guess a better way to put it. But if I said that I have this algorithm, and for me it works 70% of the time, and for you it works 40% of the time, and that's just how it is, and it's not based on any sort of characteristic that should matter. For example, let's say a job recommendation algorithm gives me better jobs or better suited jobs 70% of the time, and gives you jobs that are suited for you only 60% of the time, only 40% of the time, but that's purely based on our gender, then that's unfair, right? So fairness is not about eliminating bias, it's actually about the distribution of bias. And what we find in a lot of these algorithms, when something is considered unfair, if you can think about it as the weight of that bias is carried more heavily by a particular subgroup. And that's when we consider things to be unfair. And again, that could be based on literally being a protected class, or I expand the definition to mean any sort of an input that shouldn't be impacting the output. So a bit about the fairness evaluation tool. There's 3 parts to it: mutual information, disparate impact, and predictive parity. Mutual information is a data investigation tool that helps you identify and determine sensitive variables from other variables. In other words, just because I don't include age into an algorithm doesn't mean it might not be driving the output through a proxy. Mutual information helps you select sensitive variables based on your definition of what that is, and see how it might be related to other variables that you intend on putting in your model. The second part, disparate impact, looks at a different distribution of error for different subgroups, and those would probably be the groups that came out of your mutual information analysis. And third is the predictive parity tool. And this is a really interesting tool in classification models to enforce equal outcomes. So what's really interesting, and I don't have a slide on it because IBM's tool just came out. So Google and IBM, as I mentioned, came out with their products as well. Google uses 2 out of the 3 same evaluation tools as I do, and IBM actually, they have a more broad offering, but they actually have all 3 of these same tools as well. So it's very interesting that completely separate from each other, we're coming to a very similar definition of how we can algorithmically define and quantify and enforce fairness. So let me actually switch over to the demo itself. So a few things about the demo. And we have a paper submitted to FatStar about this. The 3 things that we looked at in order to create this tool. So the way we started is, Accenture is not a research organization. I did not do new and novel research for this. There's a massive amount of literature on fairness. And there was a really great talk at the FatStar conference last year called 21 Definitions of Fairness. And that's what inspired this tool. What I wanted to do was go through those 21 definitions and then some, and figure out what is actually something a company could use. And out of that came a framework of how to translate academic work into applied work, which is really fascinating. And what we look at is scalability, which is, I think, something that we can all understand, generalizability, and ease of implementation. So scalability meaning, is this algorithm, will this algorithm work with streaming data, real-time data, massive amount of data, and so that was actually a main barrier to implementing a lot of the fairness algorithms that exist out there. Second is generalizability, and this is actually a very important one that people often overlook. A lot of this work in the scientific community is very niche and requires very specialized skill. So for example, earlier this year, and this is actually in the Google tool, this concept of counterfactual fairness. The way counterfactual fairness would work is if I could take myself and change one characteristic about myself and see how that might impact the outcome, then I would understand if there was some fairness or unfairness. And this is a really wonderful paper that came out of DeepMind by Sylvia Chiappa and some other folks. Really went into how you can measure and quantify that difference and then use Markov-chain Monte Carlo methods to reduce that difference, thereby coming to a more fair outcome. But something like that's actually quite difficult to do for the average data scientist. What I was looking for is something that, with a limited learning curve, an average data scientist can understand. So why is counterfactual fairness so hard? Because it actually looks at causal relationships. You'd have to map out the causality of your algorithm, which actually that's not what we do, right? We make really, really good, highly correlated algorithms. We're not actually showing causality in most of our situations. So the second thing we looked at, as I mentioned, was something that an average data scientist could understand and implement. Most of our clients, so one of the first things that I was told when I started Accenture was that our clients are not very sexy, right? So yes, we have Google and Amazon and IBM as clients, but they're not going to buy AI tools from us. The companies that will have AI implementations done by us, maybe an oil and gas company, it could be a retail company, right? It could be CVS drugstores. These are not necessarily companies that have really sophisticated data science teams. They may have just gotten started in data science, and often what we're doing is actually, a lot of our work is we're moving people into the cloud still. So I have to respect and understand that the companies that I want to be using this tool, and by the way, they greatly impact people's lives. They may not have data scientists that will read or understand a niche area of research. And also, it is very, very important for a data scientist to understand what it is they are doing. What I don't want is this to be a push-button solution for what fairness should be, and you push a few buttons and it solves fairness for you. That is not at all the intent of this tool. It's meant to be a conversation. So the second part, as I mentioned, generalizability. And the third part is about integration. And again, as a data scientist myself, the last thing you want is something getting in your way when you're trying to do your job. So all the tools presented here are meant to be integrated into your data science workflow. So for example, the mutual information tool is something you can use when you're doing your data investigation. The disparate impact tool is something to use once you've finished programming your model and you have some output, and same with predictive parity. So just to walk you through some of the visualizations. So I was not able to bring a full demo because I would either have to download a Docker instance here, which you don't want me to do, or I can't connect my own laptop to the internet. But what I have is sort of a click-through demo of what we're working on. So this is an example of mutual information analysis. So what the user would do is select variables they think may be sensitive to the outcome, because again, all of this is very context specific. There may be cases in which it's totally appropriate for age to be influencing your outcome. For example, if I'm a clothing retailer and I want to show you clothes on your website, right? There are cases in which it won't be. So let's say I picked age. What this part of the tool shows is how much age is related to these other variables that are going in my model. So by the way, this paper is available. I think I'd emailed it to Larry and Michael, so if you guys wanted to take a look at it, get in touch with them or me, and happy to share it with you. This was actually prototyped on the UC Irvine German credit score data set, if you're familiar with it. So it's a publicly available data set that uses different characteristics to determine credit risk worthiness. So these are actual variables, these are actual relationships, et cetera. So if we look at these sensitive variables, I'm able to highlight how they're related to some of the non-sensitive variables. So, age, for example, is related to the number of dependents, how long they've been employed. So it's up to the user to assess whether or not they think there may be a relationship that could be problematic. Disparate impact tool is really interesting. This is working backwards. Why is it not letting me? There you go. Okay. Sorry, it's supposed to be the other way. There you go. Disparate impact tool. So disparate impact tool is really interesting. What it looks at is the distribution of your error term. So it doesn't necessarily mean there is a bias or something that'll happen. It might. So what this would look at is, let's say I picked gender as a sensitive variable, and the light blue dots are women and the dark blue dots are men. What I should be seeing is sort of an even spread of dots, and it just looks like noise. Instead, what I'm seeing is the error term is clustering by gender. That's not necessarily going to lead to a bad output, but what I do know is that my error looks different for the different groups, which might lead to a bad output. So what you can do about this, which is great, is do a bit of statistical distortion and actually improve the repair level, so to make it more homogeneous. So of course, then the question is, why don't you just crank it up to 100 and make it perfect? A, there is no perfect, and B, your model may suffer in terms of global accuracy as you increase the repair level, as illustrated here. So just a little bit on accuracy. Accuracy is a really interesting term, right? And again, it's one of those words that we just threw out there, and then now we're realizing that actually this might not mean what people think it means. So when we say accurate, I think what a layperson might think is it's correct and not correct. And actually, interestingly, some of the feedback I got is, well, how is it fair if it's less accurate, right? And to a layperson, I totally understand why people think that. But when we say accuracy, obviously, as researchers, this is how good it was in the testing data set, right? So you have your data set, you split into, you split into test and train, you train on this, and then you test on that, and maybe you iterate through a bunch of times, right? So one of the problems, and this goes back to our biased data, our different structures of bias. Number one, often these data sets are not representative of the population that they will be used for. In healthcare, it's a particular problem. Most recently, in the news, there was some talk about how prostate cancer actually impacts African American men the most in the US, yet the data set on prostate cancer is about 85% white men, right? So there's not an adequate representation. So even if you were to split into a test and train, do that hundreds of times, it actually wouldn't matter, and your model would be overfit to your data, not that it would be more accurate to a global representation or a global implementation. So I have a lot of thoughts on accuracy, because accuracy is a misleading term, and there is also accuracy within subgroups that we don't talk about that we should be talking about. But this is sort of a global rule of thumb about accuracy. A second thing that's really interesting about accuracy, by the way, is that it is not always the case that accuracy will decline. And this is actually in Chiappa's counterfactual fairness paper, where in some cases, when she corrected for the model to be more fair, accuracy increased. And I have some thoughts on why. What I'm hoping to do as more and more clients use this tool is to start performing benchmark analyses to see what actually happens to accuracy. Because right now, when we talk about there's an accuracy decline, right? But how much, right? Is it really that bad? And is that even globally true? So we saw the same thing in our model. So what we're looking at here is the predictive parity component to it. So when you have a classification model, you get your confusion matrix, you have your ROC curve, and you pick a value. And often the value is sort of picked, so you minimize the error term, again, globally, so global accuracy. So on the right, I have, again, fairness, accuracy trade-off. So one thing here, and because this tool was built with our end user in mind, one thing that the German credit score data set had was a matrix of how much it cost if you had a false positive or a false negative. In other words, if you gave someone a loan and they didn't pay it back, or if you should have given someone a loan but didn't, right? And of course, false negatives are nearly impossible to measure. There are interesting ways using controlled experiments to try to do false negatives. So what we have here instead is the concept of false positives, which I've actually lately been calling leniency. So when we think about it, most false positives probably come from the edge case, so the case where somebody may have been approved, but they were right on the border and they were instead denied. And I see it as almost like a measurement of leniency. So, let's say this is an in-person interaction. I'm like, I don't know if you'd be a credit risk. And, the person on the other end is like, look, I have a kid on the way. I just really want to get this home for my family. And I'm like, you know what? You seem like a nice guy. Here's your loan, right? So this is almost like an algorithmic leniency. But what we see is that algorithms are actually nicer in this case to men than women. And an investigation of whether this is statistically significant is useful. So again, this is all coming step by step. Let's say you've chosen gender as the variable that you want to investigate. What you want to do is have an equal outcome based on gender, and you are seeing that this does not happen. So going back to this concept of cost. So on the right-hand side is actually not your accuracy score. It is a measurement of quantified cost. So they gave us a little grid in that data set of how much it costs if they have a false positive, false negative. So we put a dollar value behind it. So again, in terms of user understandability or business impact, frankly, my banking clients don't, once you're a senior VP or whatever, they don't know or care what an accuracy score is for a model. What they care about is how much it may impact their bottom line. That's what we're getting at here. And again, what's really interesting is initially, as you improve for fairness, your cost declines. Your cost declines, meaning that you're actually better performing. And my hypothesis, not yet tested, I think it's not only because we have reduced the false positives. In other words, we've set a bar to say that everyone's, so remember when I was talking about how the bias needs to be distributed evenly? This is it, right? So the bias needs to be evenly distributed. So it's not just that we've reduced false positives. I think it's also because we've reduced false negatives. In other words, we've given more people opportunities. So in the Google tool, they call it equal opportunity. So that's for equalizing for false negatives. And I think my hypothesis is that we're seeing something here. We've given people more opportunities that we would not have. They successfully pay back their loans. Therefore, my cost is declining, and my company is making more money out of implementing a tool that is more fair. So it's interesting, again, back to this conversation of a tension between this fairness accuracy trade-off. It's not so black and white, and it invites some really, really interesting conversation. So again, to clarify this third tool, when you have a classification algorithm, this would help you select for a value that equalizes your false positive rate, or as I was calling it, leniency, and to be equally lenient for all the different groups. And really, in quantification terms, what I would say is that everyone's shouldering the same amount of bias. This algorithm is just as likely to be right or wrong or nice or not nice to me as it is to you based on gender. And that's ultimately what we were aiming for. So back to this. And then what are the gaps? So there are many. This is nowhere near a finished conversation. What's very excited about this space, and I go on arXiv just about every day to see what new papers are coming out. And actually a few weeks ago, there was a paper that came out that was critiquing some of these very same mechanisms. So I'm actually very excited to read through those critiques and start building a Fairness Tool 2.0 that takes into account and bumpers pretty much about the criticisms that were raised. So what are the gaps? One, moving from explainability to understanding and communicating. As you saw, that tool is not a command line tool. It is not a code-driven product, and that was done on purpose. What I want is for fairness in this conversation to be global. What I want is a data scientist to be able to use that tool and then take it to management and say, hey, look, here's what I'm seeing. Because to take this all back a notch, we're putting a responsibility on data scientists that's absolutely huge and critical. We're saying it is our job to decide what is fair and what isn't fair. And actually, I don't think that's right. I think that an average data scientist needs good guidance, they need the right tools, but ultimately these should not be unilateral decisions. These should be made in consensus. And something like the Fairness Tool is intended on guiding that consensus, making that discussion happen. So how do we improve communication? Second is understanding causal and not correlational relationships. So this is Judea Pearl. His latest book is the Book of Why, but he is a god in the social sciences world. You're welcome if you are an engineer. So how do we understand causality? Because what we're often seeing here, which is very problematic, leading to biased outcomes, is that we're actually finding spurious relationships, not causal ones. That's a very big difference. And then finally is how do we how do we understand context-specific biases for a low information audience? So for example, how do I explain this output to an audience that may not understand what it is I'm talking about? And how do we make it not seem like an arbitrary decision, make it understood that this is context-specific? So very quickly, as I know I'm running out of time, I want to talk a bit about governance to address unintended consequences. Talking about the fairness without talking about the governance is probably not is an imperfect approach. So I'm going to move really quickly to what I'm working on today, which is an algorithmic impact assessment. So what I've found when talking about, people call me about the fairness tool, they want me to do a pitch on it, we talk about it, I start working with the data scientists, and then they have this moment where a light bulb goes off and they realize, oh, this is actually a tool to inspire governance, which is that was the secret, actually. What I wanted was to illustrate, quantify, measure how algorithms can be unfair so that the companies can understand we need to put some sort of a mechanism behind this. So the next step that I think the community at large is taking is this concept of an algorithmic impact assessment. So building on the principles of privacy impact assessments, what are the things we need to add to think about algorithms? How do we define low, medium, high risk? And then what are the sort of safeguards and guardrails we deploy in order to address them? So this also includes concepts of model monitoring. So when you put your model out there, that doesn't mean it's done and you walk away. What that actually means is that it is your job now to make sure that you're investigating, to make sure that when it's in the wild, it's not exhibiting biased outcomes. And then the gap, as I mentioned, primary harms and secondary harms. So very quickly, and I promise I'll wrap up here. I just think this is very interesting stuff. So governance often moves via a waterfall methodology, right? So the way most governance works is that the governing body wants to understand the space, and then they want to sort of achieve this outcome. Innovation doesn't work that way anymore, right? We abandoned waterfall methodologies a while ago. Now we operate in this agile world. So the two are ultimately at odds because they don't work with each other. A waterfall methodology moves too slow for agile, and agile just seems to be constantly confusing for a waterfall methodology. So that's the primary gap. Another gap is that we think a lot about the primary harms, as I outlined earlier. Now, what about the secondary harms? What about all the ways in which algorithms are shaping all of us? So as I mentioned earlier, my next work that I'm doing is on what I call algorithmic determinism, measurement bias plus a feedback loop. So in other words, if we have an imperfect measurement, because we're often using proxy measurements to get at a thing, because now we get at concepts, right? We get at criminality, or we get at goodness of fit for a company. These are not purely easily quantifiable things. And again, we're back in social science world here, where we try to measure things like happiness, right? Social capital. So if there's a measurement bias, but then you build an algorithm around it that is a self-perpetuating feedback loop, what we're actually doing is creating our outcome instead of responding to it. Instead of shaping the outcome around what truly is, we're making assumptions about what we think it is and then pushing it towards that outcome. So that's the next thing that I'm working on and thinking through. All right, so just a brief review. Our goals: fairness, accountability, transparency, and explainability. Our types of biases: experimental and social. Concepts of addressing and redressing, so technical tools, governance tools. And then finally, thinking to the future: how do we understand primary versus secondary harms? Thank you. Stay up here for Q&A?
Yes.
Okay.
That would be great. So we do have time to ask questions, and I'd love for there to be not just questions, I'd love there to be discussion. So we do need to use the microphones. And my desire isn't that we make Ramon to be the answer person for everything, but that if other people have thoughts to share in response to certain questions, be very open to that. And I will say, and so good, we got some people lined up, and my high school football coach used to call me QB, and it wasn't because I was the quarterback, it was because I was a question box. So if you don't ask, I will, all right? So let's start over here.
Okay. First of all, thanks for this talk. This is really interesting. And I'm completely out of my area here, so I'm going to ask a couple questions, and they may be completely dumb questions.
You say there's no such thing as dumb questions. I got to ask dumb questions, but I'm sure you will not come up with dumb questions.
Right. Well, you might want to wait on that judgment. So the first thing I was trying to figure out is, it seemed like in a lot of places, and this is just my intuition, when you fix one kind of bias, you will introduce another. The example I could think of easily is life insurance rates for men and women. You can make sure that men and women get the same rates, but then women wind up paying more. They get less return on their investment because they live longer on average.
Yep.
It seems like that's always going to be a problem in this space where you're going to be choosing which bias is acceptable. Is that?
Yeah, absolutely. And so that's one of the critiques, by the way, of predictive parity in that paper. And I remember the author's name, Sam Corbett-Davies. He's the primary author on it. He has a lot of really great work in this space. And what the suggestion is actually to do group-specific modeling. So, for example, in insurance, what you would then do is build a model. If you know that there is such a disparate difference in the wild between men and women, as you would create one set of algorithms for men, another set for women.
Right. But I mean, intuitively, it sounds like, I imagine saying, okay, so our predictive model for whether you're not going to reoffend, we're going to have a different one for blacks and whites.
Right.
And I think, man, that doesn't
and actually
sound good at all.
that inherently would be illegal as well. And you're absolutely right. We're crawling into like the ethical and legal conundrum. And my answer is there is no good answer. Currently, so the papers that I cite, the papers that I use for this are probably only about a few years old. This is a very, very new space. And even a few years ago, this was more of like a thought experiment that some people thought would be kind of cool. And now it's like, oh, people are using our stuff, right? So I agree. I think there's going to be a lot of testing and growing. And you're asking a very appropriate and a very right question.
Okay, thank you. The other question I was going to ask is a simpler one. You talked about or maybe different at least, you talked about the feedback loop. You could imagine the thing where your algorithm for predicting who should be released on parole, if that's biased, then maybe that bias, maybe that fulfills its own prior, okay, people get let out later, maybe that makes their outcomes worse. My question is, can you, maybe this is just per, specific for the application, when you are designing, when you're applying one of this, it seems like one solution would be to have sort of control group thing, like, okay, some parole systems use this AI, some don't, and as long as you have a reasonable control group, then you could at least see, okay, are we seeing a divergence between these two?
Yeah, absolutely, and you're 100% right on that. So experimental design is not actually something that a pure engineering space or most companies are very familiar with, and I totally agree with you that this is probably the best way to deploy things. Because even then, these consequences are unintended. The reason why we need systems of governance is that we can't think of everything. We can't think of every way it can go wrong. We can highlight the ways in which we think it could go wrong and do what we can for it and keep an eye out for it. So something like having a test control would be really, really wonderful. I think the thing for us to think about is, because these are actual human beings, this is why we have like IRBs in academia, right? Because we can't do these things to actual human beings. Well, now that we are, what do we do when something goes wrong? So let's say we do the thing, and actually our control group tells us that your algorithm is completely off, but now I've not given these 10 people parole who I maybe should have, maybe not. So I think within that is also we need to think what that invites is a conversation about systems of redress. But you're 100% right. So that's actually how some of our clients sometimes get false negatives, because we don't know. I don't know if I didn't give you a loan if you would have paid back the loan. What they sometimes do is actually they'll identify, let's say, 1,000 customers or something, and that would have fallen on the no part and we're on sort of the edge, grant them a loan and sort of see what happens.
Oh, that's cool. Okay, thank you.
Yeah.
Hello, one comment and then a question. An example of a feedback loop would be, say, for example, predictive policing, where if you constructed a network graph of people who might be in the system and then their known associates, regardless of if they've been in the system, and then if you take those known associates and then apply more policing actions to them, some would say harassment, constantly looking in on them, you're sort of shining the spotlight in that area, then you think that you found more evidence of crime.
Absolutely.
Where you might have actually just caused the person to commit more because they've given up because they're being treated unfairly, or you're just looking at that area far more often, and then you say, yes, we found that they offended, and then you've verified your algorithm.
100%. And then if you think about a secondary harm of that, it increases mistrust in communities, right? So primary harm, agreed. You will find more people and put more people in jail, and you'll further ostracize or harass a community. Secondary harm, there's an increasing mistrust then between the police and that community as well. Absolutely.
Exactly.
That's always the example that I give.
Yep, exactly. So my question is you mentioned something interesting about causality versus correlation. And this is a very hard problem. So what are your thoughts on doing this in a tool setting?
So you would probably really like the paper that we wrote for FatStar, and in using those three sort of constructs of how we created this tool, I really, really, really wanted to use the counterfactual fairness work. But what I realized is that most data scientists have no idea how to do causal mapping, right? I think that's a very difficult question that goes back to fundamentally how data scientists are taught. It is taught more as a programming exercise than a thinking exercise that applies to humanity. And causal mapping has, I'm sure there's a lot of programmatic ways to do it, but really it's something you can do on a piece of paper, but you just have to be trained in it. Solving it, not sure. So Google's fairness tool actually does have counterfactuals. What I worry is, and this was a very big concern of mine, I don't want people just poking at things because it's a nice user interface and just, having outputs they don't really understand. I used to teach data science before I joined Accenture, and to me it's very, very important that people understand what they're doing and don't just push buttons and do things because they have a pretty interface, right? And that's why I chose not to use counterfactual fairness. I think that Judea Pearl's work is getting a lot of traction. He is also amazing on Twitter. So if you follow him, he explains a lot of stuff very, very clearly and concisely. So one of the problems with trying to do counterfactual fairness, in some cases, it is a reimagining of how, if we're thinking about actual AI, like deep learning networks, it is a reimagining of how deep learning networks work. And again, if I'm thinking from an implementation perspective at big corporations, they're really just not interested. Because, and I don't say that cynically, I say that realistically, right? They're trying to deploy AI. They're going to do it today. There's all these companies. They're like, why am I going to do this totally brand new? None of these companies do this stuff, right? So it's a difficult road. And this is why we're having this conversation today before all these products are everywhere, even though they're almost everywhere. We're still in early enough days that we can try to do something about it. An excellent question that I do not know a good answer to.
So are people, I remember doing some reading at one point that at least some companies were doing randomized control trials to try and tease some of these things out because there's only so far they could get with just observational data. Is that commonplace, or is that just some edge companies that are going the extra mile?
I would say it is not commonplace. It is, I don't know if I'd call them edge companies. I think this has to do, again, what I was talking about at the beginning about this idea of conscious capitalism. There are some companies that just get it, that the space is changing, and it's not just, okay, let's look at the law, let's adhere to the law, And so it's the companies that have that kind of mindset that are looking more into, we actually have to be proactive to think about how this might impact the world when we deploy the thing. So those tend to be the companies who want to invest in this kind of thing, absolutely.
All right, thank you.
Yeah.
If I could ask next, after I interject with a related question about feedback loops.
Mm-hmm.
So there's a lot of practice today where trying to augment training sets with simulated, like adversarial type trained generative models. And what are your thoughts about the slippery slope, perhaps, for creating feedback loop with such methods.
Yeah, absolutely. So bootstrapping is a conversation we actually have a lot in the social science space. So for example, if we're trying to determine, this is why, let's say national polls can be very unreliable if you try to break it down by, let's say, race or region, or worse, cross race and region. What you do is you would just take a small sample of what you've got and then sort of amplify that upwards. And actually in my dissertation, I use this method called multi-level regression and post-stratification. Pretty much what that does is it takes a national level, let's say, survey, and I can break it down to what the state level results would be based on, basically it's a lot of multiplying. If I know the distribution of, let's say, race, gender, income in the country and how many people were of that group, and then I know what the distribution is in, let's say, New York State, I can sort of multiply it through and weight it appropriately. What I worry about then is that, and this is what happens in my world, a few people then drive the opinion of their whole group. And sort of anecdotally, you don't just put one black person on your advisory committee and they represent all black people. You don't put one woman on your advisory committee and they speak for all women, right? Quantitatively, it's the same problem. You don't just take, the 10 black people you could get to answer your poll about whether or not you'd vote for Donald Trump in Southern California, and then amplify that upwards, say, this is what all black people in Southern California think. So that is actually a very valid concern with bootstrapping, is that unless you know that this is actually an appropriate outcome that you would see, you might risk multiplying a niche opinion.
Excellent, thank you.
Thanks for the very interesting talk. I enjoyed it. I really liked your comment about agency, and I thought that was interesting. I read a story recently that reminded me of, about somebody who had been fired from their job, essentially by their company's computer system. And they went and talked to their boss, and their boss said, well, I didn't do that. And they went and talked to HR, and they said, well, we didn't do that either. And it ended up taking a month for them to, convince the superiors that this is just the computer's fault, and nobody had the agency to override that decision. And I guess my question is, how do you envision kind of ensuring that agency is implemented in algorithms? Is that something that you can require that people are able to give feedback that's incorporated into the actual training of AI models? I guess how do you see that being implemented?
What a great question. There's a talk I do called Moral Outsourcing, and the example you just gave kind of reminded me. I refer to, if anybody here has read any philosophy, refer to Hannah Arendt's Banality of Evil, so at the end of World War II, as a world, we wanted to understand how entire nations of people could be complicit with the genocide of a subgroup. She goes to the Nazi trials, the Eichmann trials in Jerusalem, and comes back with this amazing book and article for the New Yorker, where she writes about how the face of evil is not, just Hitler. It is not like a person doing a bad thing. It's actually all the people underneath who just think they're doing their job. So all of that is a very dramatic way to absolutely highlight your point and the need for exactly what we're talking about here. And also, lay people think that algorithms are some sort of objective magical truth. It's like a magic box of real. And if there's some sort of an output, well, it must be right because the algorithm. I'm actually frankly surprised that enough people who weren't necessarily algorithmically trained felt that they could challenge the system, and that is very few people who feel like they have the agency to do that. So how would we engineer that? I do a whole design-led thing. Whenever we do a product at Accenture, we do a lot of design-led thinking sessions, and I do one entire project session on human-centric design. And I know that's a word that gets kicked around a lot, a term at least. So that's one thing we think about, and one big part of it is I go through an exercise where you design a product for whatever, and then the next thing I say is break your product, right? Like break your toy. How would you hijack the system? How would you break it? How would it go wrong? And then think about how you might address that problem. One thing would be, I'm surprised that this person got fired without a human having to actually do the firing it seems like. And what does that mean? Not that, so there's a very similar parallel between algorithms used to set bail or to determine whether or not someone should get bail or not, and that's already being used today. It's specifically in New York State. So you might find some really interesting parallels there. So a friend of mine, Christian Lum, she's been doing this work for a really long time. So she's been developing mechanisms and methods. So it's sort of the same thing, right? You have judges who are not quantitatively apt people. And actually what you're fighting against is people want things to be really automated. It's not that people actually get this conversation. What they really want is the algorithm to kind of tell them what to do, because they assume it's right, they assume it's driven by data, blah, blah, blah. They've internalized that people have individual bias, whatever. So what judges actually want is like bail, no bail, like that's what they want, right? What we know happens is that you get these edge case people, there's significant amounts of measurement bias, et cetera. What Christian has been working on is A, creating better systems, better algorithms, but B, how do we create some sort of an output that the judge understands that doesn't just tell them thumbs up, thumbs down, but gives them a reason why. And actually in a longer version of this talk, I talk about some of the different tools that are out there to improve explainability. And there's some really great, there are actually some really good products out there, or like open source tools out there that you can use to improve literal verbal explanation of an outcome.
So it sounds like maybe part of it is that the AI model tells humans, maybe I think this is an edge case,
Yep.
or I know this is an edge case.
Yep.
You need to use your judgment now,
Right.
please.
Yeah, absolutely. So it'd be something like a percent, something like a few reasons why. So there's a good one, there's a good paper called Lime, or it's actually called Why Should I Trust You is the name of the paper, and it's literally that. So if you have this is actually for a visual, no, it's not, it's actually for any text-based classification. So let's say the example they use is a doctor is diagnosing a patient with something. A doctor can't just say, oh yeah, you have cancer. Why? Because the algorithm told me. What it actually does is it gives relevant explanation. So yeah, there are ways to do it. So absolutely, it would be some sort of an end user meaning decision maker tool that would give them an explanation and give them the ability to say yes or no, or to investigate further.
Thanks.
Thank you.
Thank you. And Peter will give you the last question.
Okay, so my first comment is I think in the explanation what might be useful is an uncertainty or an error bound. I know at NIST we're very big about that. So when you say this multiplying doesn't tell us, you could say, well, we have the mean, but the variance is so wide we don't know. But the question I wanted to ask was about when you talked about governance, you said you wanted a chain of command. What I wanted to understand is why you believed it was best that the governments had to be a chain of command. Now, there's great wisdom in my management that guides me, but I was wondering if there was a specific reason for saying, yes, we want the person at the top to call the final shots versus no, we want a different group of people to sort of make the larger decisions.
So I guess I'm using a bit of shorthand when I say chain of command. It's not really that there's sort of this one decision maker at the top. So I guess maybe I'll walk you through the process that we're doing at Accenture. So as I mentioned, Accenture, 450,000 people all over the world. It's a really interesting governance problem, right? So we have so many AI teams and they're making all this stuff. And to be honest, there's a range of skill and ability. So we're also working with an audience that sometimes actually doesn't know much about programming AI and how to deal with problems and fairness or whatever, or they're contracting with a third party, right? So, I want to make a tool for hiring. Oh, great, HireVue, you do this stuff, I'm just going to use you, right? So I'm also working with a wide range of skill and ability. So how do I govern that? We can't have everything roll up to the top, right? Because nothing would happen. The likelihood of, our top steering committee is our chief technology officer, chief analytics officer, our general counsel, myself and my co-lead. I cannot imagine how the five of us would get together once a month, let alone like every 2 weeks, like Microsoft's Ether group purports to. Microsoft, it works because everything rolls up to Redmond. Accenture doesn't have a actual headquarters. We're all over the place. So in solving that, which I think is a good representation of how a lot of these things will look in the real world, what I'm thinking of is adequate. So this is the fire alarm thing, right? So I use the fairness tool. I think I see an issue. I'm just an analyst. I'm like, I think there's a problem here. Not sure what. Some fire alarm, which goes to the next level person, which could be like an ombuds person. So you're getting like hot off the presses because we were just talking about this yesterday. Goes to something like an ombuds person who will help you think through the, the issue and see if it really is a problem or not a problem, then that might escalate to something like a red team, like drawing from the cybersecurity world, which would try to go into your system, hack it, break it, see if it's actually possible. But then these top level people, really what they're for is not to go into the nitty-gritty of every project. For them, it's actually defining what are the ethical principles, what does it mean to be fair, because otherwise we're going to have individual groups or people making their own judgment calls. So we can say something like, it is unacceptable for us to discriminate, let's say based on race, gender, and ability, even if it is not legally required in whatever country that we're in, right? That might be the principles that they come up with. What would also go up to them is some sort of crazy, weird edge case that your existing framework couldn't solve. So, I can't think of one off the top of my head, but if you have something that's not easily resolved by your red team, by your ombudsperson, and by your team on the ground, then it would go up to them. So they're more like an advisory council. So I'm imagining like advisory council meets monthly, quarterly, and sort of red team is always sort of ongoing, ombudsperson are always ongoing. So we're thinking about how do we create these roles like liaisons between data science and legal. That's actually a really, really important role to explain legal issues to data scientists and quantitative issues to legal folks. That is like an absolutely critical role. I think there should be one on every team, or at the very least one in every region, so that that person can be involved. So there's a lot of middle management.
So thank you so much for the great questions. We have some momentum on conversation,
Yes.
which we would like to carry forward. So you all are cordially invited to join us for an informal lunchtime discussion with Ruman. It'll be a kind of, first come, first space available. We will be meeting out this hallway and down across from the main entrance to the cafeteria on this side of the hallway. Back in a small corridor across from the main entrance, there's dining room A and B. And so it's one room set up for us today, and it's a large conference room table. And so we'll be able to bring lunch, sit down, and continue our conversation. Your options are to go to the cafeteria and then come back across the hall, or for the nisters that might have a brown bag or something like that, you can head off and bring it and come back. What we'll do is we're going to give Ruman a bit of a break. So we won't take too long, but let's say by about 10 of, we should have our lunch, those that are going to continue the conversation, we should have our lunch and be in dining room A and B. So it gives us about 15 minutes to kind of hunt and gather and then reconvene. Ruman, thank you so much for coming and talking about this. And I want to express thanks on behalf of our two communities here today, the NITRD AI R&D Interagency Working Group, and also the NIST AI Community of Interest. And so thank you so much.
Absolutely,
and
it's been my pleasure.
I look forward to conversation in just a few minutes. So,
Same.
Thank
Great.
you.
Thank you.